because of these structures. These are renal corpuscles, which are confined to the cortex. The renal corpuscle, remember, consists of a blood capillary network here, the glomerulus or glomerular capillaries, surrounded by the collecting chamber, which is called the Bowman's capsule or glomerular capsule. Okay? We have a lot of tubes in here. These tubes would be the proximal convoluted tubules, the distal convoluted tubules, and parts of the loops of Henle. Now, for the most part, I'm not going to ask you in the slides to identify proximal and distal. You can very easily on the models. However, you got something like this. This tube that's coming out of the Bowman's capsule, what would that be? That's the proximal convoluted tubule. All right, so in that case, I think it's fair game to ask that. You can see that on the models too. Here's a little more magnification. And again, you can see the blood capillary network. That's the thing in the center. It's not quite in focus yet. You can see. Okay, so that's just a ball of capillaries. That's the glomerulus and glomerular capillaries. Here is the Bowman's capsule. You can see a little cavity here. And here's the proximal convoluted tubule, which comes out of the Bowman's capsule. Now, most of the renal tubule, the wall is made up of simple cuboidal epithelium, which you can see here. Like the small ducts in the salivary glands, simple cuboidal epithelium. The small bile ducts in the liver, simple cuboidal epithelium. And the small pancreatic ducts in the pancreas, simple cuboidal epithelium. Same thing here. But there are some areas where the epithelium is different. For example, right here, the wall of the Bowman's capsule, you can see, is simple squamous epithelium. See the flattened cells, a single layer? Much like we see in blood vessels. So that's an exception. Another exception is what we call the thin segments of lubricant. You can see that on the models. Versus the thick segments. Thin segments are just that. They're thinner. Their wall is simple squamous epithelium. The thick segments, again, is simple cuboidal epithelium. Another exception is the macula densa. These are specialized cells in the walls of the distal convoluted tubule, which are simple columnar epithelium. Okay? You can see that on the models. Most of the rest of the wall is simple cuboidal epithelium. So look at that on the models. Okay? So again, most of the renal tubule is simple cuboidal epithelium with these spherical nuclei. The exception again, the wall of the Bowman's capsule, the glomerular capsule, simple squamous. The thin segments of lubricantly, simple squamous, and then the cells of the macula densa in the distal convoluted tubule, simple columnar epithelium. Okay, and look at that on the models. Okay. All right. So if you're asked, what tubes would you have in here in the cortex? What tubes would you have here? Okay, proximal convoluted tubules, distal convoluted tubules, and parts of the loops of Henle. And that's all part of the nephron. Okay? We have a tube in here that's not part of the nephron, in the cortex. Where does the urine go from the distal convoluted tubule? Into what?
The collecting duct.
The collecting duct. The collecting duct. So that's not part of the nephron. All right? We also got blood vessels there too. What capillaries do you have in the cortex? What blood capillaries? Maybe it's too early to ask these questions. Peritubular capillaries. Those are the rounds around the parts of the nephron in the cortex. And remember, the blood that's fed in those capillaries comes from the efferent arteriole, which is the same blood vessel that drains the glomerulus. Okay? But again, you ask what region this is, it's what?
Cortex.
Cortex. Why? Because of the glomeruli, or the renal corpuscles. They're only found in the cortex, as is most of the nephron. But these are very obvious. So if you see those, you know you're looking at the cortex. So let's look at the medulla.